Hello everyone, this is Amar. In this video, we'll see how to draw the shear force and bending moment diagram. So let's start the video. In first case, we will calculate the support reactions from load diagram. In second step, we'll calculate the shear forces at all the points, and accordingly we'll draw this shear force diagram like this. And in third case, we'll calculate the bending moment at all the points, and accordingly we'll draw the bending moment diagram. So let's start the video with calculating the support reactions. So you can see one image of simply supported beam with a midpoint load of 1 kN acting at point C. So this beam is simply supported. Now here we have to calculate the support reactions. Support reaction means this value of RA and value of RB. So in this case we'll consider that for equilibrium condition of this beam, sum of all the vertical forces acting on this beam will be equal to 0. So in this case, we will assume that the upward force will be positive and the downward force will be of negative magnitude. So here you can see RA and RB upward forces, so it is of positive magnitude, and 1 kN downward force, so of negative magnitude, -1 equal to 0. On rearranging this, RA plus RB will become equal to 1. Now in second, this will be your first equation. So in second case, we'll consider that sum of moment at point A equal to 0. So moment is nothing but it is the product of force into displacement or distance. So in this case, if there is a clockwise movement like this, then we'll consider it is of positive magnitude, and if there is a anti-clockwise movement due to load, then it will be considered of a negative magnitude. So at point A, if you consider there is a 1 kN load which is 5 meter from point A. So due to this load, this will create the clockwise movement. Beam will rotate like this, so it will be having positive magnitude 1 kN acting at a 0.5 meter distance, and this RB load will create the anti-clockwise moment, and it is at 1 meter distance from point A. So minus RB into 1 equal to 0. So on resolving this, 1 into 0.5 is nothing but 0.5. This will go to this side, so we'll get the value of RB, which is nothing but 0.5. Okay, so if we put the value of RB in this equation, we can get the value of RA. So it will be 1 minus, shifting toward this, 1 minus 0.5. So the value of RA will also be 0.5 on solving. So in this way we can calculate the support reaction. Now next move on to the calculation of shear forces. So shear force is nothing but sum of all the vertical forces acting at a point to the left and right section of the beam. Okay. Now we'll calculate shear force at just left of A. So if it see just left of A, there is no load, so shear force will be 0 kN. And to the right of A, if you see, we can see the 0.5 kN load is there. So we can see shear force at right of A will be 0.5 kN. So first we will draw XY line, which will indicate that this 0 kN load at this point. Then we have 0.5 kN load at this point A, which will be of positive magnitude, so it will move upward of 0.5 kN. Now we will consider shear force at point C to the left. If we see to the left, then we can see only this load, which is of 0.5 kN. So you can see that it is of a 0.5 kN. Now to the right, if we go to the right, this will be 0.5 positive and this will be 1 kN negative, because it is a downward force. So 0.5 minus 1 will become minus 0.5 kN to the right. So it will go in downward direction because this is a negative sign. so negative 0.5 kilonewton. Now we'll consider shear force at point B to the left. If it's to the left, it will remain same value, that is of minus 0.5 kilonewton, and to the right, if you see, we have 0.5 kilonewton load and 0.5 kilonewton load, this two upward and this one negative load minus 1. So on solving we'll get 0 kilonewton. So in this way we can draw the shear force diagram. So this is a flow of your shear force diagram like this. Okay. Now let's move on calculating the bending moment. So bending moment is basically sum of moment at all this point, that is A, C, B. So moment is nothing but again force into distance. So we'll first start with the point A. So at point A there is a 0.5 kilonewton load which is acting at distance 0. So bending moment at point A will be 0.5 into 0 distance, which will be 0 kilonewton meter. So at point A bending moment will be 0. So you can see here 0 point is there at point A. Now at point C we'll move from left to right like this. So if you see at point C, if the bending moment at point C will be what? We can see to the left there is a 0.5 kilonewton load acting at 0.5 meter distance. Now because of this load there is a clockwise moment, so we'll consider the moment to be positive magnitude. So 0.5 which is at a distance of 0.5. So 0.5 into 0.5 will become 0.25 kilonewton meter. So 0.25 kilonewton meter is the bending moment at point C. So here you can see 0.25 kilonewton. So if there is a straight line in shear force, then it will be represented as a inclined line in bending moment. Okay. Now let's move to the point B. So bending moment at point B, we can see there are two forces of 0.5 and 1 kilonewton. So 0.5 will create the clockwise moment and this 1 kilonewton load will create the anti-clockwise moment. So 0.5 will be at a distance of 1 meter from B and 1 kilonewton will be at a distance of 0.5 meter. So on solving, bending moment at point B will be 0 kilonewton meter. So here it will again move to 0. So in this way we can draw the shear force and bending moment diagrams. Hope you like this video. Thank you for watching.